Hey everyone, it's me, Miss Billman, and this is the Unit 4 Lesson 4 homework. This time we're looking at pyramids. So, in the past we looked at prisms or even just a flat shape. This is a pyramid, so we're going to use the shape of the base to help us know what to name it. We're not naming it Carl, we're not naming it Gray, we're actually naming it something. So it has 6 sides, which is equal to a hex. I remember because 6 has an X in it. So it's a hexagonal pyramid. I mean, that's a mouthful. Like, if this was Wheel of Fortune, I definitely would be able to guess it correctly. But I'm using the base to help guide me there. Number 2, this looks familiar, right? It's a triangle. So I would say it's a triangular pyramid. Ooh, very fancy. Number 3, when I look at this base, I'm going to notice, hey, this is a rectangle. It seems weird when we're like, no, a rectangle, that's a prism. No, actually, this is a rectangular pyramid. And they remind me of the buildings in Vegas. I think it's like the Luxor. I think that's it. It reminds me of that. So number 4. Again, looking at the base, it's a triangle. So I would name this a triangular pyramid. Now, if you look at number 2 and number 4, they are a little bit different. It's kind of like they're rotated, but it's still the same kind of pyramid. Pretty cool. Number 5, I look at the base. It's a square. Now, it's not square-tangular. I definitely heard someone say that before. It's just a square pyramid, but square-tangular sounds pretty legit. I'm going to count the sides on this one. 1, 2, 3, 4, 5. 5 is a pentagon, so this is a pentagonal pyramid. I think I definitely heard someone say pentangular. That's interesting, and you know what? We'll just tomato that, and I'm going to say pentagonal pyramid. Let's look at number 7. Will this net form a triangular pyramid? Explain. So that net at the right, now it doesn't look like number 2 or number 4. But it's definitely going to be a no. Now, this would need another side, kind of like I'm drawing in right there. It is not a net. And being able to decide, well, is it a net or is it not, that's a huge skill that I'm really proud that I've seen you guys do super awesome in class. So this one only has 3 faces. Unfortunately, that would not make a complete net. The net would need to be able to cover all sides of it. But you know what? It gets an A for effort for sure. Number 8. The perimeter of the base of a hexagonal pyramid is 48 inches. Now, perimeter, that's the distance around. So I'm going to just draw myself a hexagon. A hexagon has 6 sides, so there's my hexagon. It looks kind of sketchy, but I'll keep it around. And it has a total perimeter of 48 inches. The base of a regular polygon, that's the base what it is. What is the length of the base of one of the triangular faces? Oh man, so really what's asking me is how long is each side? Now when I have a 48 as my total, I need to divide that by how many sides there are. This has 6 sides. Or I might know, it's going to be 8 because I know 8 multiplied by 6 is 48. Either way, make your strategy known and really own your learning. Now, I could double check this answer by counting each side. 8 plus 8 plus 8 plus 8 plus 8 plus 8, or all the way up to 6 sides. That's a great way to check my answer. Or I could say 8 multiplied by 6, and I should get 48. So going back to the question, when it says, what is the length of the base of one of the triangular faces? It's going to be 8 inches. It might be hard to see in my picture, but I'm even drawing in the triangles that would make it a hexagonal pyramid. Number 9, Vinny found the area of a triangle with a base of 5 inches and a height of 6 inches to be 30 inches squared. What error did he make? Ooh, okay, so we got to roll it back mentally and dig around in our toolbox. And we know that the area of a triangle is base multiplied by height divided by 2. And it's a common mistake to not divide it by 2. So when Vinny was finding the area of a triangle, he didn't end up dividing that by 2. So yes, 6 multiplied by 5, that's equal to 30, but Vinny didn't divide by 2 to get 15. This would be a different story if Vinny was finding the area of a rectangle, He could definitely say the area would be 30, but unfortunately for Vinny, in this case, it truly is only 15 because he didn't divide the product by 2 to get a quotient of 15. So explain how you know how many triangular faces any pyramid will have. Now, it's not like, oh, I'm Facebook friends with it, and that's how I know. It'd be cool. I mean, I don't know if I'd want to be Facebook friends with shapes, but I know that I can figure out how many triangular faces a pyramid will have by how many sides it has. If you go back to numbers 1, 2, 3, 4, 5, and 6, when we looked at the base, we saw, oh, it has this many sides. So it must have this many triangles coming off of it. Like in number 1, a hexagon was in the middle. So that has 6 sides, so it must have 6 triangles. So the number of triangular faces is equal to the number of sides it has, especially that base. There's 1, 2, 3, 4, 5, 6, and that means I would have 6 sides on this shape, which is a hexagon, and I would have 6 triangles making that pyramid coming off of it. Now, I could even try with another shape, and I'm going to try my best to draw an octagon, which has 8 sides, and here comes, it kind of looks like a sun, but here comes my triangular faces that make the pyramid. I can go through and count it, how many sides I have, but I know it's 8, so I should have 8 triangular faces coming off of it. Even if I just had a triangle as my base, I should have 3. That's how many sides it has. So knowing how many sides it has is powerful.